All right, sign test is the next one we're going to look at. And the sign test is very similar to a Z or a T test in that we're going to be testing, but not the mean. We're going to be testing the median. Okay, and the reason we're testing the median is because the data is not normal-ish, if you will. Okay, and so when we do these guys, excuse me. So when we do these kind of problems, what we need to ask ourselves is well, okay, I'm going to be testing to see if it's, I want to test the median is this versus the median equals that. I could do a lower tail, I could do an upper tail just like before, but the median, because the data is not normal-ish, okay? So suppose I had, oops, that was kind of weird. Suppose I had some data, and I'm going to put that data up here in a minute. And suppose I make the statement the median is 8. And of course the opposite of that is median is not 8. Okay? And if the data was like, I don't know, 3, 4, 5, 5, 6, 7, 2, 5, 4, 10, 11, 1, 3, 13. A person might look at that and go, well, if I put these in order, it's clearly not 8 by putting them in order and finding the middle number. That's obvious. Okay, there's only 3 that are above 8 for crying out loud, and there's a bunch below it. But that's not quite what we have in mind. In essence, that would be finding the sample median. Okay, but the idea here is that I've taken a sample. These 13 numbers that are seen over here. They're a sample from some other population. And just like when I take a sample before, I could have then said, well, okay, so from this sample I found X bar, but then I'm going to try to say something about mu, which I don't know. So if I were to lay these out in order and say, all right, 1, 2, 3, 3, 5, 4, 5, 5, 6, 7, 10, 11, the middle one would be the 7th term, yes? Yes, so 1, 2, 3, 3, that's 4, 5, 6, 7. The median would be 5. That would be like our sample median, okay? But sample median, schmample median, that doesn't do much for us. So how the sign test works is, well, if the number is less than what we said it was, 8 in this case, we're going to put a negative. Hence the sign, because it's less than. It's below it. Oh, but if it's a greater than, we put a plus, because it's above it. And what we're going to do is we're going to pay attention to the smaller number. So in this case, there are 3 negatives, and there are 10 positives. This guy here, you see, will be our test statistic. Okay. Now, for fewer than 26, so like 25 or less, there's a chart in the back of your book, and it's on page, well, I don't know what page it's on. I'll tell you what which table it's in. It is on table J from the back of your book. Okay, so table J. And it is lined up pretty easily, so it has 1 and 2-tailed tests. So across here it'll have 1 tail, and then down below it'll have 2 tails. And so in this case we had a 2-tailed test, so I'm going to go over here to where it says 0.05, and then I'm going to come down this column. Okay, and then over here on the side it asks for what n is. So over here, there's a little column that says n. And you're like, well, what's n? Well, n is the number of numbers that are not 0. So in this case, we had 13. We had 13 pluses or minuses, if you will. Okay? Because what would have happened if we'd have had an 8 in that data set? It would have been a 0. Does that make sense? We'll do one of those in a minute. So I come down this column and I find that 2. 2, that's my critical value. 2. Okay? Now read the fine print. The test value is No, here it is. The reject the null hypothesis if the smaller number of positives or negatives is less than or equal to the value in the table. So if this guy right here, if that guy was less than or equal to the 2 from the chart right here, we would reject. It's not. So what do we do? But it's not. So it's not. So we fail to reject. Now, by failing to reject, what are we saying? That means we're sticking with the idea that the mean is, in fact, 8. Now, for a lot of people, that's very annoying because you're like, wait a minute. It's not anywhere near 8, Jay. Remember, this is a very small sample size, and remember that the sign test is a very non-powerful test. It's weak, if you will. It's not like a t-test. It's not like a z-test. This test is really, really, really weak. Okay, you would have had to have 2 out of the 13 numbers would have to be greater than or less than, either way. 2, if this was 2 and this was 11, okay, or if this was 11 and this was 2, then we'd make a difference. But what does that mean? It would mean you'd have 11 numbers on one side of the proposed mean, which is goofy. You think 11 to 2, that should be enough. Again, not a very strong test. So just follow the things, but make sure you pay attention to the fine print. Now, here is another. Median equals 10. Median not equal 10. And so, I don't know. Let's go knock it out. Cool, whatever. And so if we go and put signs on, these are less than 10, so I'm going to give them negatives. These guys are 10, so they get zeros, and they won't count anymore. And so our n this time is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Our n is 10. We did not include the zeros. Okay? And we had 3 negatives, and we had 1, 2, 3, 4, 5, 6, 7 positives. Duh. And so 3 is my test statistic. Okay, so I'm going to go down the chart, and let's just say we have alpha is 0.1 this time. By going down the chart, and this is a two-tailed test, clearly, and I go down to 10, I see that my test statistic is 1, or my critical value. My critical value is equal to 1. Well, 3 is bigger than or equal to 1. It would have to be less than or equal to 1. It's bigger than 3 is bigger than 1, so I'm failing to reject. If it would have to be 1 or 0 to get me to reject. So fail to reject. H naught. And what is that saying? It's saying that the median is not significantly different from 10. Does that mean it's actually equal to 10? No, not really. We just can't refute that. Okay, it doesn't mean it is. It just means we can't refute it. Okay. Yeah, here's another one. Now, this next one I'm going to just go ahead, throw it up here right now. Median equals 17. Median, less than or equal to 17. Median greater than 17. There we go. And this time I'm going to write down a whole bunch of numbers. Because, well, that's the kind of guy I am. You need it to be in order in any way, shape, or form. There's 32 of them. That's cool. Nice. Now, as I go through, I'm just going to go through and highlight them. So negative, 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 negative. 2 zeros. Positive, 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 positive. Bigger than 17, of course. Positive, negative, negative, negative. Positive, 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 positive. Positive, positive, positive. Negative, positive, 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 positive. Cool. And so there are, from the negatives, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 negatives. There's 2 zeros, and I had 32, so that would put us 20 positives, I think. If you count for me, that should be true. 20 positives. As you go to the back of the book, it doesn't go up that high. And that's because if it's bigger than or equal to 26, you're going to do the following. You're going to make a z-score. And the z-score is just like this. It's x plus 0.5. Okay? Now you might recall back in what do I want to say, in 243 when you did percentiles. That's where that 0.5 is coming from, because this is a really this is a binomial distribution in essence. Either you're above or you're below. And that's kind of where that deal is coming from. Okay? Now what is n here? Our n is 30. So when we plug this in, you're like, well, what is x, Jay? Well, x is the smaller of the pluses or minuses. So in our case, it's 10.5. Oops, there should not have been a plus there. This is a z-score. What is it always? It's x bar minus mu, yes? So there should have been a minus there. Just pay attention, Jay, what you're doing. Not to get too big a hurry. There we go. It's a z-score, just like any z-score. So n, that's 15. The square root of 30 over 2. That is my standard deviation. Now let's break it out. Well, I'll just do it on Excel, because why not? Negative 1.643. Ooh, that's scary crazy right there, boys and girls. Nice. Now, notice how this was an upper-tailed test this time, yes? Now you're like, wait a minute, upper tail? That seems weird, Jay. Well, okay. Keep in mind that this upper-tailed test, and this is when it gets a little goofy sometimes, this is an upper-tailed test originally, you're right. However, what we're saying is this, okay? What we're saying is we ended up taking the smaller of the two of them, correct? We ended up taking the smaller of the two of them. And by doing that, we're always going to end up with a negative here. So the question will be, okay, is when we make this cutoff score, we got to make sure we do it correctly this time. Okay, so if I was going to use an alpha 0.05 on this problem, right? And if it should have been an upper tailed test, that would have put us at 1.645, correct? That's why I whistled, by the way. That's pretty close. But because it's a negative, because we did the smaller one will always give us a lower tail at that point. That's the only thing that's a little weird about some of these non-parametrics. There's some kind of rules that they're a little tricky sometimes. So negative 1.645. And that, friends, is right there. And so just barely, what are we going to do? Fail to reject H naught. But just barely. And what are we saying by that? The median rather, is not significantly different from 17. Okay, something along those lines. Okay. Again, Pay attention to that. The original deal up here was an upper tail test. That's true. But this x right here, is always the smaller of the two. Okay? Which means that this guy will always end up being negative. So when you go to find your critical value, just make sure you're using always on the lower side for this z business. Okay? That's just how the game's played. It just kind of is how it is. So just be aware of that. Don't freak out by it or anything. Just know that that's what it's going to be going into it.